Hey, this lesson is about how to find the area of a triangle. And there's my target up there on the board. I can find the area of a triangle. We're going to use what we've already talked about right here with what we know for the area of a rectangle to be base times height. I need you to have this sheet to follow along with. So if you would, look at that sheet and look at number one. Number one says, draw a picture of each triangle under its name. Then write a sentence that describes the triangle. So, there are a lot of different types of triangles. You have right triangles, acute triangles, and obtuse triangles. So I'd like for you to make a sketch of a right triangle. It has a right angle in it. I'd like for you to make a sketch of an acute triangle where all angles are less than 90 degrees. And I'd like for you to make a sketch of a triangle that would be obtuse, which means it has one angle that is larger than 90 degrees. When you're finished with that, I would like for you to make sketches of triangles that are based on classification of leg lengths. A scalene triangle has no legs congruent, and a isosceles triangle has 2 legs congruent, and an equilateral triangle has all 3 legs congruent. So you could pause the video and make your sketches, and when you're ready to start the lesson on area of a triangle, you can start back here. Okay, so let's talk about how we already know that the area of a parallelogram or a rectangle is base times the height. And if we take a rectangle or a parallelogram and we divide it in half, where we connect the vertices that are opposite one another, we would have a triangle. So if the rectangle's area is base times height, the triangle's area would be 1/2 of that. So the formula for area of a triangle is always 1/2 base times height. So what I'm going to do is I'm going to use that triangle for any type of triangle that I'm given, and I'm going to be able to find its area. So if you would, look at your example number 2. And on number 2, I want you to notice that that's a right triangle. And if you count the base distance given to you based on the units is 4. And if you count the height of that triangle is 5. So you don't even need this diagonal length because the formula says you only need the base and the height. And remember, the base and the height are always making your right angle. So what I'm going to do is I'm going to plug into the formula to find this area. Area is equal to 1/2 base times height, and I'm going to evaluate into that formula. 1/2 times, my base value is 4. My height value is 5. And then I'm going to simplify this. I'm going to multiply my numbers first. So I'm going to multiply out 4 times 5, which is 10, and I write that down. But I make sure that I bring my 1/2 out there, and I'm going to multiply it. This really is, associative property. I can multiply whichever ones that I want to first. Like I could multiply 1/2 times 4 and get 2 times 5 and work that out. Or I could multiply 4 times 5 and get that answer, which I said is wrong, which is 20. So I need to now go ahead and say 1/2 times 20, which gives me 10. And I'm going to label this as 10 square units. See, I made that error a while ago. 4 times 5 is 20, and I wrote that down right there. If you turn over, we're going to look at an example of an acute triangle and try to find the area of that one. Remember, you can pause this video at any time so you can make sure that you're caught up with what my work is. So on the back for number 3, we have an acute triangle drawn. An acute triangle has all angles that are less than 90 degrees. So they have the height drawn in for us with a dotted line. And what I'm going to need to find out is what the base and the height are. So I'm going to count the units on that grid to make sure I know the base for that triangle. And when I count it, I get 1, 2, 3, 4, have a 7. And all you need to know now to find the area is the height. And when I count the height, I should get 4. So now I'm going to use those values. And I'm going to plug into my formula once again where I have 1/2 base times height. I'm going to evaluate in. So I'm going to write them in as 1/2 times, my base value is 7 and my height value is 4. I'm going to use associative property. I'm going to multiply these two numbers together first. Go ahead and write that 1/2 down. I'm multiplying by 28 because 7 times 4 is 28. And then 1/2 times 28 is really the same as 28 divided by 2. So my answer there is 14 square units. So really what I know is that there are 14 square units in that triangle. And it's, not so easy to count all those square units because some of them are cut or split by the diagonal lengths of the triangle. It's easy to use this formula when I know what it is. Area equals 1/2 base times height. That's for every single triangle. I'm going to do one more example, which is number 4, which is the obtuse triangle. Remember that an obtuse triangle has one angle in it that is obtuse. There's no way that a triangle could have more than one obtuse angle in it because it just wouldn't work. Couldn't draw it. So my obtuse angle, looking like that right there, when I connect it with my other legs, I have an obtuse triangle. The height is denoted to me outside of the triangle. So what I need are the links on the triangle right here that touch and make that right angle. So there's the base length. Look at where my arm is. I need to count that distance. So when I count it on my grid, I get 4. Then I'm going to count the height. Notice that is extended outside. That's called an auxiliary line to your visual. It's a helper. When I count that distance, I should get 6. So now I'm going to find the area of this triangle by using base and height values of 4 and 6. I'm going to evaluate into my formula again. 1/2 times the base, which is 4, times the height, which is 6. I'm going to use that associative property again. I'm going to multiply my numbers out, and that gives me 24. And then I multiply 1/2 times 24, and that gives me 12. And then I'm going to label my answer in square units. So now you know how to find the area of any type of triangle based on the classification of angles. A right triangle, an acute triangle, and an obtuse triangle. And what I'd like for you to do in the spaces that are provided is I'd like for you to make up your own example of each type of triangle that we did as an example and find each one of those triangles' areas. Thanks.